Physical firewalls and hardened perimeters are no longer sufficient. As resources move into the cloud, the traditional network boundary disappears, replaced by a complex system of distributed credentials. When we investigate cloud breaches, we rarely find attackers exploiting inherent software vulnerabilities. Instead, they exploit the risks created by configuration errors. In this shared infrastructure, a single misplaced permission or a stolen password grants an attacker the same level of access as an internal administrator. To secure this architecture, we must map specific threats directly to the cloud layer they target. We will analyze 5 attack vectors: IAM configuration failures, active session hijacking, cloud resource exhaustion, malicious token manipulation, and overarching data privacy risks. Defending the cloud requires transitioning from static network defenses to dynamic, identity-centric security models. We start at the foundational layer, identity and access management. Misconfigurations here are the primary root cause of massive data exposures. Consider the frequent reports of AWS S3 bucket leaks exposing raw, personally identifiable information. At this scale, a single error echoes across millions. An overly broad public read-write policy allows unauthenticated connections to bypass security controls and directly access internal storage objects. Threat actors deploy automated scripts to continuously index the internet, hunting for these misconfigured storage buckets. The architectural solution is to strictly enforce role-based access control, ensuring users are granted only the absolute minimum permissions necessary to perform their tasks. That access must also be gated by multi-factor authentication. MFA is an operational necessity to prevent automated credential stuffing attacks from breaching the IAM boundary. Without rigorous, constantly audited IAM configurations, external actors do not need to hack your network. They can simply walk through the front door and pull the raw data. Once the initial login is secure, the threat landscape shifts. Attackers move up the stack to target active, authenticated user sessions. Service hijacking is straightforward. This is the theft of primary login credentials, allowing the attacker to impersonate a legitimate user right at the authentication prompt. This diagram outlines session hijacking, where an attacker targets the active session token mid-transit. Watch the identity provider pass the validated token to the client. A man in the middle intercepts a copy. The defense is strict TLS encryption across all traffic, rendering the intercepted data unreadable. Encryption alone is insufficient. Operations teams must enforce rigorous session management, implementing mandatory token expiry times and forcing periodic reauthentication. The back-end architecture must also possess mechanisms to instantly invalidate and revoke those tokens the moment a session anomaly is detected. Securing the initial login is strategically useless if the resulting session token remains vulnerable to interception while moving across the network. Beyond identity and access, we must protect the availability of the system itself, specifically against denial of service and distributed denial of service attacks. Traditional DDoS mechanics rely on resource exhaustion. An attacker floods a target server with volumetric traffic until the physical hardware capacity crashes. Cloud environments use autoscaling. When malicious traffic spikes, the infrastructure dynamically reacts by provisioning more resources to handle the load, creating a compounding vulnerability. This results in an economic denial of sustainability. The goal is to force the victim into incurring massive financial charges from thousands of autoscaled servers.
Mitigating this requires active network edge countermeasures, starting with aggressive rate limiting to throttle excessive requests coming from a single IP block. We also rely on anomaly detection and automated traffic scrubbing to identify and drop malicious packets before they reach the application layer and trigger scaling. In a dynamic cloud environment, an unmitigated DDoS attack functions as a direct financial exploit, extracting capital through forced resource scaling. This brings us to one of the most advanced persistence vectors in the ecosystem, the man-in-the-cloud attack. This attack bypasses complex passwords and MFA policies by targeting the local synchronization clients used by mainstream cloud drive services. The initial compromise phase typically relies on social engineering or malware to gain access to the user's local endpoint device. This map shows the attacker's target, the locally stored OAuth token. Once inside, an attacker's script replaces the legitimate token with a malicious one. The client accepts it and seamlessly begins syncing all corporate data directly to an attacker-controlled storage node. Because the new token is technically valid, this massive data exfiltration occurs silently. It triggers no security alerts and prompts no MFA requests. The primary enterprise countermeasure for a man-in-the-cloud attack is deploying a Cloud Access Security Broker, or CASB. A CASB sits between the endpoint and the cloud. It automatically replaces standard OAuth tokens with unique encrypted tokens. If an attacker attempts to swap one, the malicious token fails decryption at the proxy, and access is firmly denied. Neutralizing man-in-the-cloud attacks requires extending our security perimeter all the way down, encrypting local application tokens directly on user endpoints. Beyond direct technical exploits, we also have to address the strategic vulnerabilities inherent in utilizing third-party infrastructure. When encrypted traffic and automated backups physically cross international borders, it immediately triggers severe compliance risks regarding data sovereignty. Multi-tenant hardware creates further privacy issues. Organizations often lack the visibility required to guarantee absolute data redaction and deletion protocols on physical drives they do not own. There is also the operational risk of vendor lock-in. Relying on proprietary security tools prevents an organization from rapidly migrating infrastructure during an active threat. Robust cloud security requires a strategy that actively manages both the strict legal compliance and the operational constraints created by the shared responsibility model. All of these vectors complicate the core forensic challenge. Cloud environments are highly dynamic, with resources constantly provisioning and deprecating on demand. Traditional static post-mortem forensic techniques are largely ineffective in an architecture that is ephemeral and constantly shifting. This syllabus excerpt highlights a core industry focus: overcoming cloud forensic challenges. Investigators require specialized, automated tools designed strictly to capture transient API logs and CloudTrail data in real time, before the virtual machine vanishes. Defense against modern threats requires integrating identity, session state, and traffic filtering into a single, unified security architecture. Security operations centers must continuously audit IAM policies, rigorously monitor the behavior of active OAuth tokens, and validate their CASB proxies. Securing the invisible perimeter is never a one-time configuration. It is a continuous, active audit of trust and behavior.